Hey guys, this is Sig from Elder.io, and today we're going to be doing a Golang tutorial on the consumer interface pattern, which is a really popular design pattern in Go, and it's a little bit difficult or confusing for people who are coming from traditional languages like C# and Java, because sometimes in those languages you define interfaces for the thing that's exporting the functions as a blueprint, and Go is a little bit different. So we're going to show you how this works using an example. We bring over our trusty editor and see we've got 3 files for this example. We've got foo and bar.go, and we've got a main.go to run the thing when we're done with it. And if we look at bar.go first, all it is a simple struct that has 4 different functions. So bar is capable of saying hello in a couple of different languages, and all it does is just print the correct thing to the terminal. And so now we want to implement foo. And foo is supposed to be able to say hello in one of these languages, but foo, for example, only speaks English, but it's supposed to use bar to actually accomplish this. So how would we do that? What we could do is we could say foo somehow uses the functions that bar has available, but how does foo know what functions bar has available? This is typically where things like interfaces come in. But in traditional languages, you would define an interface on bar and say the blueprint for bar could be something like this. Root for bar is actually that it has always assumptions. It has to say hello and so on. And then we could, even without knowing what's happening in those functions, we could use that interface inside foo. The thing is, in Go, what you actually should do is you should use consumer interface patterns, which basically means you declare the interface on the thing that needs what you're trying to use. And as a result, you only really stope it down to the things that you actually need. So I said earlier, foo is only going to be speaking English. So foo really only cares about one thing, which is the say hello function. It doesn't care about the say hola function or one of the other languages. So what we can do is we can return interface on foo, and we can call it bar. This is a local interface. We can say it needs a function called say hello. That's all that foo cares about, all right? And we could call this anything really. We could call this foo bar. Doesn't really matter, but we'll call it bar. It's because this is a part of a subset of bar. And then we'll say we're going to store a reference to bar on our foo. If we then create a constructor for foo, say this is it. Let's create a new foo, right? I'm going to pass in a bar reference, and we're going to return a pointer to a foo. So if we go ahead and instantiate a foo, like so, we can set bar to bar. And now we can implement some kind of business logic that uses the thing that we injected. So this is using another design pattern called Dependency Injection, which is a prominent design pattern in Golang. Let me know in the comments below if you want to have a video on Dependency Injection. But essentially what this now allows us to do is we can create some functions. For example, a function, let's have a look. Let's just call it greet. And this greet actually uses the underlying bar, let's say hello. This is how foo greets people. So what we've done here is we've created an interface declaration on foo, saying something's going to be injected into foo. It's going to live up to this blueprint up here. This is the consumer side or client side, is sometimes called interface declaration. It's going to be injected that has a function say hello that we can call. And then in the greet function, we actually call say hello. So how could we actually use this? So in our main function, we go out here. It's an empty main function. We start by instantiating bar. So first we say we need a bar, because that's one of the things we start by doing. We just instantiate it, and we'll tip a reference of it. And then we'll instantiate foo. And foo, we're going to use the constructor. So I'm going to say new foo, I'm going to pass in bar, like so. So now we can then call foo.greet. And what we've done here is we've created an instance of bar. And bar, if you remember, has all these different things. It has say hola, it has say puya, that knows all these languages. But foo only really cares about English. And so we inject that into foo. But foo has this declaration of only caring about say hello, because we'd use the consumer interface to say, of all the things that bar can do, I only care about say hello. And we're then able to call say hello under the hood. So if we go ahead and compile this, build our main function, and run it, we can see that it says hello. So what is the benefit of using these kind of these kind of things? One of the big benefits is that, let me just close my terminal here. One of the big benefits is that foo is really scoped down to only the things it needs to know. So foo, you've said here, foo only cares about say hello, and that's all it knows about. It doesn't care about all the other things that bar can do. This is a really powerful concept when it comes to things like testing foo, because what we can do is, even though bar is this complicated thing, maybe bar does all sorts of other things. It goes into a disk, it does all sorts of crazy things. We don't really care about them because we can just, in our testing, for example, mock an interface implementation of something that can say hello, and that's all through cares about and we pass that into foo, even though in the real world, foo actually gets a reference or pointer to the real bar, if that makes sense. And so it's a really powerful pattern that's used throughout Golang, and it's something that can be difficult to wrap your head around, but hopefully this example has illustrated how it works in practice. Let me know if you want to see more videos on Golang, and please like and subscribe to the video, and thank you for watching.